this context, I happened to hear two presentations, one by HPCL and another one by MRPL, very fittingly called as GOAT and COAT. I think there are sessions on some of these technologies. I think the larger challenge for India with feedstocks and naphtha crackers versus gas crackers and the yields which are there in comparison to what happens in, say, the Middle East or US, is going to be the ability to integrate with downstream petrochemicals, and that is something we will talk as the session moves on further. I would now like to invite a veteran from the catalyst industry, Mr. Vipan Goel from Grace. And the question I have for you, sir, is as the refining landscape shifts towards petrochemical integration in a very severe fashion, catalyst innovations from companies like Grace, in terms of feedstock flexibility, potential maximization of petchem precursors, yield maximization, of course, ultimate cycle lives are something which customers would be looking forward to. Could you throw some light on what developments you have on those areas?
Well, thank you very much. So I'm glad that audience can hear us loud and clear. And I'm also actually even more glad that we can't hear each other very well. So don't mind the repetition if there is any. So talking of landscape, so the issue is where does one stop or where does one start actually? So let me take you back to 1942. And as in the opening it was mentioned, there are a lot of youngsters. Mr. Agarwal said that they have invited to this RTM, or now it's ETM. So it's 1942, for them, maybe the movie 1942, the love story. But also there was 1942, where the Second World War was at a major turning point. And also 1942 for India was Quit India movement. All these things we know. But the little known thing, and that's important for our industry, for the refining industry in particular, for FCC aficionados even more particularly, that the world's first FCC catalyst, or the first FCC plant itself, was started in 1942 in May. And the reason for that was what I said in the beginning, because it was the Second World War, and there was a need for aviation turbine fuel. So many of you think, probably, even the older people, that FCCs were gasoline machines, which they were. So the very first need or the demand was for aviation turbine fuel. So there was a plant in Baton Rouge and Exxon Model 1 FCC. And no prizes for guessing who made the catalyst for that. The catalyst name was DaviCat. So it's Grace Davison Company at the time. The world's first catalyst manufacturing plant, first alumina-based catalyst manufacturing plant, was in 1942 May, commissioned side by side with when the FCC plant was started. And that, at that time in 1942, was in Curtis Bay. And I'm pleased to say that plant still operates, world's oldest plant, and we are proud owners of that. So that catalyst, the difference, and I was asked to talk about the evolution. So since that was the time when ATF was needed, later it became that gasoline machines, these were known worldwide. For India, it never was. It was still middle distillates, LPG. The economy was, I would say, product slates were skewed because of control economy. But coming back to the story of the evolution of catalyst and that of the marketplace requirements, so from gasoline, or you call it distillates, the needs evolved. And today, as we speak, after so many years of that, and that Curtis Bay plant, we supply to one of the world's largest FCC from that plant, from Curtis Bay plant. The difference is, now it's a maximum propylene unit. In those days, each molecule was not as respected. There were a lot of bottoms which were left unconverted. So there are two things which I would say in particular happened in terms of landscape. One, on the product side. The product side, the requirements changed, and every molecule, as Reliance is very proud to say and fond of saying, they want to convert it to petrochemical, and so do most plants in the world. Today, its refinery economics does not work if we are not into kind of trying to convert that every molecule to petchem. When I started with FCCs, and I love that unit, of course, as an operator, that time there used to be, let's say, 3 to 4% propylene. And today there are max propylene units with 20%. Those days, this was not at all the focus. In India, particularly LPG, only for the domestic consumption, for the use in the burning in the stoves. So the whole thing changed. So how did it change? It was not only barely the hardware, the technology. Much of it technically or theoretically remained the same. It is the same kind of cracking, basic principles are still the same. But the catalyst evolved from that low alumina catalyst, and some people still make that, which was known as silica sol. From that low alumina, 10-12%, to now about 50% alumina. These are the catalysts, very robust. And then you want to maximize propylenes. Obviously, you want to limit hydrogen transfer reactions. So what do? You reduce rare earth. Today everybody talks of rare earth and China putting up embargoes and not. But if you would remember, I think 10, 12 years back again, similar situation happened. And Grace was the first company to come to the market with the first rare earth-free catalysts. So we can make rare earth-free catalysts, we can make maximum stabilized, maximum rare earth catalyst, we have bottom upgradation catalysts, and all so that today's scenario in India, for example, if you will talk of the two major technologies that have taken place, one is we are all very proud of that, INMAX type of units. The gentleman sitting next to me, Alok Sharma. So R&D, we are so proud of that INMAX unit. So the biggest one coming up in terms of, as far as we are concerned, in terms of catalyst usage, is at Gujarat Refinery. Imagine this, resid to propylene, the first unit in India coming up of that high technology. Then there is, again, a matter of pride. Bottom to barrel technologies, like Rajesh talked about. The first unit in India after decades, and as somebody has said, I think it was I wouldn't name it, everybody knows that, there are decades when nothing happens, and there are weeks when decades happen. So in terms of, if I were to extend that analogy, and I started working in refineries from early 80s and on FCCs, I used to wonder, nothing changes. I attended my first refinery technology meet in 1994 or 93. I think it must have been second or third or fourth. And now 36 years after, we are here today with such a illustrious group of people. So much changed in the process. So we have this HPCL Vizag, they have evaluating bed unit. The first time a resid technology, again, we are proud to say, art hydroprocessing, we are supplying that catalyst for them, for the large unit. So there is evolution in the marketplace, and Catalyst has kept the pace by upgrading various kind of catalysts, whether it is for handling difficult feeds or meeting the market requirements. Thank you.
Thank you, Mr. Goyal. I just recollect how we adopted to FCC technologies by taking a gasoline machine and India trying to make it a diesel machine in the early 80s. And from there on, we moved on to higher gasoline maximization and then to petrochemicals. And today, all of us are aspiring to look at FCC as a machine for petrochemicals while also producing gasoline. It's indeed been a huge evolution for us in India with respect to catalyst technology, especially FCC technology. And from there, I think the aspirations are on to move on to use fluidization as a basis to produce crude to chemicals, which is indeed something which we are looking forward to in the years to come. We now move on to another critical area where India is actually silently trying to revolutionize reduction in carbon, use of LNG as an important tool for both auto fuel and for chemical businesses. I would pose this question to Mr. R.K. Singhal, Director Business Development from GAIL. Sir, the question is, with the increasing focus on integrating gas with petrochemical value chains, especially led from cheap gas being available in the US and in the Middle East, how is GAIL positioning itself in the emerging refinery petrochemical gas-based synergy models? What do you say?
Yeah, good morning, everyone. Well, actually, the challenge again, before GAIL is manifold, it's threefold. First is to meet the growing energy demand more efficiently, especially in light of the crude prices coming down. The expectations from GAIL is to provide cheaper gas also because the crude prices are coming down. And then to drive economic growth by producing value-added petrochemicals where again margins are squeezing. And then cut down the carbon emission, which is a natural pressure everywhere. But in this trilemma, I still feel that GAIL is positioned uniquely to seize the opportunity. GAIL, with its 16,000 kilometer pipeline network, is integrating the entire gas-based economy, connecting all refineries. And refineries are using natural gas to cut down the emissions. In field of petrochemicals also, we know that demand for petrochemical is growing, and against India's per capita consumption of 13 kg, global average is even 38 kg, what to talk of developed economies. So the potential is huge. But the problem is we have to perhaps find more efficient ways. Like GAIL was the first to set up a gas-based cracker way back in 1999. So again, we have taken a stride forward, and this time we are again first to bring PDH technology in the country and setting up a propane dehydrogenation project, which will definitely provide better yield through for propylene. And ethylene propylene remains the main source for producing most of the petrochemicals. So achieving better yield in propylene or ethylene is very important. So PDH will that way help increasing propane yield and perhaps cutting down the cost of PP, downstream polymers as well. Then we have also taken a lead this time to acquire a plant, a PTA plant through NCLT acquisition, wherein we have acquired 1.25 million ton capacity, and this plant will produce PTA. PTA, again, India is grossly deficient in PTA, where in China, they have a capacity of roughly about 65 million ton, and India has barely 5 million ton capacity. So we are 1/30th of China's capacity. So this plant will start producing sometime in December, January this year, and will cut down India's import by 1.25 million ton. So that is how we are in different areas. We are trying to bring in value-added products and use natural gas, not for us alone, but for all other petrochemical plants and refineries. This is the challenge.
So thank you, Mr. Singhal. I think the challenge for India is actually manage different feedstocks, ranging from ethylene, potentially ethylene, high reach yield, ethane, to naphtha and to multi-feed crackers, and then being able to produce value which is competing with the global opportunity. And in all, I think a larger integration of petrochemicals and trying to have a range of petrochemical plants which maximize value from C2 all the way to C4, C5 chemicals, and the developing demand as our GDP continues to sustain is going to be something very interesting for us to look forward to in the future. I now move on to an old friend of mine, Mr. Bharat Goenka. I used to know him from his IFP days, and then he moved on to Shell, and today a new company, Nextchem. Bharat, your question is, your company is very active globally in waste to chemicals and circularity projects. How can such technologies be deployed in Indian refining context to support low carbon transition and waste valorization?
Thank you, sir. Thank you for your question. Indeed, this is a very relevant perspective because recently we are talking a lot about taking every molecule valuable out of refinery by integrating refineries and petrochemicals. But the next step is how do we reduce the import of fossil-based molecule in the refinery? And how do we kind of look at those molecules by which are non-usable right now, either in form of biomass, industrial waste, or in terms of municipal solid waste, and how to integrate the molecular value inside the refinery. Because currently, most of the cases, we are taking thermal value out of it by incineration processes and just making sometimes power, but mostly just thermal value. So the technology which we have deployed few times in Japan and now doing it in Europe also, this technology basically makes synthesis gas out of you can say, landfill waste. Any waste which goes into landfill can be starting from fertilizer waste, from bio waste, from industrial waste, refinery waste, in form of liquids, having some microplastics, having some metals, so unsegregated waste, and creating synthesis gas in an efficient manner. So, and this is also, in a way, provides a stable, renewable synthesis gas as compared to if we speak about the RE-based power or RE-based hydrogen generation system. So, you know, we know coming from refining industry that refining industry is little averse to bringing dirty feedstock inside its refinery. They always want only the cleanest fuel to come. But if you look at the longer term perspective and specifically need of the country, where we are having quite large waste generation, I do feel that if we can utilize this waste into generating the molecules and bringing them in the refinery, then this molecule can augment, number one, the need of refineries' own energy requirements, so scope 1 and scope 2, but also it can be used into the streams which are going out of refinery in terms of fuels by augmenting part of the fuel coming from the waste. So this is very specifically, I am talking about our gasification process, which is high temperature process for unsegregated waste.
Thank you. I think this is an interesting topic. We are getting there. We started at least managing bamboo, rice waste, cotton waste, and slowly trying to get into those areas as well. Hopefully, with the huge natural resources of waste which we have, this will become some technology which can be considered seriously for the future to compete with our other opportunities on manufacture of feedstock for petrochemicals and other requirements. Thank you. My next question will be to Mr. Balachandran from Baker Hughes. Baker Hughes, most people know of as an upstream company, and we all know about desalters. But I think they are also experienced globally and have technologies and opportunities for potential improvements in decarbonization and to manage, to reduce to scope 1 and scope 2 emissions, technologies which can help Indian industries. Can you elaborate on that, Mr. Balachandran?
Okay, thanks for the question, sir. First, I would like to start with a statement. Sustainability is not a choice, it's a mandate. Okay? So when you talk about, people know Baker Hughes as an upstream company, but we are a full stream company. So we work in upstream, midstream, and downstream. So I'm going to talk, we heard a lot from the panelists talking about technology improvements in the plant. So what here I'm talking about is on the digital transformation, how I can augment their production, their output, the throughput can be better with the digital transformation in place. Okay, so that's one piece of the story. I want to talk about 3 different points. So one is on the digital transformation, second is on the carbon capture, and third is on the green hydrogen. Okay, to talk about the digital transformation, so BH has a platform called Cordant, so wherein we have asset performance management, so we have process optimization, and also the emissions management. It's a 3 different platform. It's in a single platform, 3 different solutions, which has been implemented in some of the companies in the Middle East and in South America. So wherein they have seen the productivity improvement, the overall throughput improvement about 20%. Okay, so how is it possible? So I'll just give you one example. So there's an LNG plant in the Middle East wherein they started implementing this predictive maintenance solution, and they were able to improve their throughput from 77 MTPA to 100 MTPA. It also reduces the unplanned maintenance, which is typical of any plant in the refinery industry. And talking about the other 2 technologies, one is on the CCUS technology. When we talk about CCUS, there's a $1 billion opportunity in India by 2030 to capture carbon. And there's not many technologies which can actively capture carbon today. So there's one technology called chilled ammonia process, which is well known. Probably that's used in many of the sectors, but it's not feasible in all geographical zones because of the temperature limitations what it has, and also the levelized cost of carbon capture. So there are other technologies which are getting developed as we speak. So there's a compact carbon capture which works on a rotating packing bed. So when you talk about rotating packing bed, it reduces your footprint by to 1/5. So this is the technology level, which is at TRL5, which will come into effect probably in 2-3 years' time. So that's one technology. And when you talk about green hydrogen, so green hydrogen, I want to divide it into 3 different sectors. So green hydrogen, one is on the production side, one is transportation, and one is utilization. So when you talk about production green hydrogen, definitely we need electrolysis process. In India, I think there's a lot of investments happening on electrolysis manufacturing. But I would beg to differ. The technologies which India is trying to invest in is probably not the most energy efficient one. So when you talk about alkaline electrolyzers, when you talk about photon membrane electrolyzers, and there's another technology called solid oxide, which is not technical, the TRL level is pretty low, but the electrical efficiency is close to 80 to 90%. So this is a technology which Baker Hughes is currently investing in. So probably it will see the light in the next 3 to 4 years. And the energy required to produce hydrogen is much lesser compared to the other 2 technologies. It's about 20% less. So it's going to be a huge boost for the hydrogen production one. And second is on the hydrogen transportation. So hydrogen transportation, we need the gas pipelines. There's as I was talking about the GAIL pipeline, so 20,000 kilometers across India. And if you want to transport hydrogen, currently it is not possible. So we are trying to see how we can blend hydrogen with methane and send it across so that the end user can use it. Currently, because of the hydrogen being a light gas and there's a lot of leakage and safety issues, 6% is what we are able to achieve till now. If it becomes 20, probably it's going to be economically viable. So I think that's a technology which we are pushing to get through. The hydrogen embrittlement is a big challenge still. And it's an open research. So we have not found a solution on the material which can handle hydrogen embrittlement today. And when you talk about downstream, so once the hydrogen can be used in refineries, so there's a national green hydrogen mission which is already in place when we talk about 5 MTPA. And predominantly, I would say 50% of this green hydrogen is going to be utilized by the refineries. Okay. So currently, it's an SMR process where they use gray hydrogen. So there's a process wherein the green hydrogen and gray hydrogen will be blended as we go along. In 5 years' time, probably it's going to be converted into green hydrogen completely. So these are some of the technologies which we are investing in. And probably in 2-3 years' time, I think we'll see a lot of things working towards a greener solution. Thanks.
Thank you, Mr. Balachandran. You have covered a range of technologies and probably made my job easier by combining 2 questions I had into one. We'll move on to our next speaker, Mr. Prabhudas, a veteran from our refining industries. HMEL has been an early refiner in India to adopt deep integration of refining and petrochemicals. How do you see such integration helping Indian refineries become more agile, future-ready amid the global energy transition as well as the disruption you see towards deglobalization in a true sense and the need to become self-dependent? Over to you, sir.
You have put so many things in one question. I thought I'll come here and address that. But before that, thank you very much for giving this opportunity, Mr. Ramachandran. And we have with Sanjay Khanna ji, Agrawal Sahab CST, Panekar Sahab, Tukhan Sahab, Agrawal Sahab EIL. I feel little belittled in front of all the galaxy here. I'll start with, this integration of petchem. And how did we start and what is it, that integration? And, very nicely, Mr. Rajesh mentioned about oil to chemicals, and we feel very proud that, percentage-wise, it is very good. So let me start there and then come to what is it that we are doing and what is it you all can think of doing it. Percentage-wise, crude to chemical, the more chemical it appears, it is very good. It's our perception. Crude to chemical, what is defined in chemical has to be seen very carefully. Right? I must have mentioned that, supposing crude is $50,000 a kg, a ton, polyethylene, polypropylene, 80,000-90,000. What you make in petchem is benzene, xylene, toluene, C6, CFB, FS, other. They're 40,000, 30,000. So what we should be looking at, crude to money. Previously, I used to come and tell, let's go to crude to pharma. We are trying to do. Crude to chemicals we are doing, crude to pharma we are doing, but what is more important is crude to money. Percentage-wise, I can tell you, in HMEL, if you put only polyethylene, polypropylene, we are 16-17%, but you put all the chemicals, we are 30%. No use. I don't want that 30%. I want that money. Where is the money? So this integration should be thought only in terms of what you get. You should go down. Somebody says, we make 1,3-butadiene. Why don't you make rubber? Why do you stop? Why do you stop at benzene? Why don't you make phenol like people are doing it? And more. So don't stop. What we have started as refinery, we stop. When we make, PP, we fall very proud. PP bana liya. But the point is, why can't we go up to the end? Why can't we go the value chain? API is 5 lakh. 5 lakh a ton, 10 lakh a ton, and we are talking 50,000. So think of crude to money. That's very simple. And what we did, agility he mentioned, why put all the energy, all the products from refinery to petchem? Integration. You make something and put it in petchem. Is this integration? It's waste of resources. I had a refinery, I had a petchem. And what we thought that, naphtha will produce in refinery and put it in petchem. Good idea, integration, all good. But then now I'm making from that diesel and buying naphtha from outside and putting in petchem. I'm making more money. You should have agility to change your fuel. I've got gas connection. Sometimes I buy, or sometimes I don't buy. I put it in hydrogen. If it is cheaper, I buy gas. If it is naphtha is cheaper, I put naphtha. You should have agility. Very simple. So, and there should be exchange of streams. Petchem produce a lot of hydrogen. The refinery can take it. They produce pi gas. Refinery can take it. There are products, there are steams in refinery that can be taken in petchem. Agility. We should be working on agility, how to really integrate and get maximum money. That's what my thing will be on agility. The products also, we can work it out in such a way that we go downstream, both in petchem and refinery, and make value-added product. We can give you a number of examples, but I will leave it to the next time. Thank you.
Thank you, Mr. Prabdas. As usual, you tend to disrupt our thinking and amaze us with your sense of humor and reality. I think finally all of us are here to make money, to build that GDP, to become Viksit Bharat, very relevant to the context of what we are discussing today. I'll move on to the next topic on net zero. This question is to Dr. Alok Sharma. What are the key thrust areas from an R&D perspective for Indian refineries to align to net zero, especially around hydrogen, carbon capture, and the circular economy pathways, which appears to be much more important for us considering our population and the huge amount of natural waste we generate? What do you?
See, in line with our national goal of net zero by 2070, Indian Oil has announced that we'll be net zero by 2046. But this will be covering scope 1 and scope 2 emissions. And to achieve these targets, we have a outlay, means there is a current outlay of about 2.4 crores. 2.4 lakh crores of rupees has been already been given for this in next maybe 10 years, for next 10 years. And so how this net zero will be achieved, there are various facets for this, and we feel that energy efficiency is going to play a critical role in this, and a program called Sprint has been launched by Indian Oil, and the focus is mainly on the core side, and we are doing a lot of energy efficient and programs are being taken up in these under this Sprint program. And then coming to the technologies part, for achieving this net zero, there are different, like we can have CBG, we can have 2G ethanol, like biofuels can play a critical role. Then hydrogen can play a critical role. Then carbon capture and utilization is also going to play a critical role. As far as CBG is concerned, we have set up some about four or five plants right now. There are some issues with the plant for which is there for with the paddy straw. So handling the paddy straw, we are facing some issues in getting this plant stabilized. Though slowly we are getting to the stabilization of the plant. Similar problem is being faced in 2G ethanol, where again the paddy straw, we are facing problem in the feed handling side. Otherwise the process is all okay, but the problem with the feed handling is there. Then coming to the SAF side, see, as you some of you might have heard that Indian Oil is the first company that to get this CORSIA certificate, and we are going to start our SAF production to meet the CORSIA guidelines by. So we will be quite early. I can say here that by next March we will be producing at least 1% of our total ATF production will be through UCO co-processing. Then we are also tying up with some of the other players for neat production of SAF, as well as we are going ahead with the alcohol to jet program for meeting the mandate of SAF. We are also working on like used lube oil, like recycling of the lube oil, and we have developed a process there where we can get this base oil, ULO can be reprocessed, and we have a technology where we are using the clay and then hydroprocessing to get the oil which can be used again. Again, co-processing of non-edible oils in DHDT also, that was tried by us in 2013, and I feel that to meet the mandate of even the biodiesel part, we can directly go for co-processing of these used oils or used like non-edible oils for getting the mandate of biodiesel also, so that we can co-process in DHDT and get the better diesel. So these are the our initiatives on the biofuel side. Then coming to the hydrogen side, see we, as you know, the electrolyzers are coming up, and the first electrolyzer plant has already been ordered. See, till the hydrogen is to be used for a captive use, I feel that it is okay, and the price which has come about $5, 397 rupees a kg, is a very good price, I can say, because see, we produce hydrogen in refineries at about say $2 to $2.5 a kg. But once it is being transported, then the major cost comes there. And just to mention here that we are buying hydrogen at about $8 to $9 in our labs at R&D. Though we produce in refineries at about $2, but we buy it at about $8 because the transportation of hydrogen is a big challenge, storage and transportation. So we are working on those facets also. We are trying to see that if we can first produce hydrogen in economical manner. So to do that, we are working on biomass gasification to produce hydrogen, and we have got very good, I will say, success in this, and we are going to scale up this plant for biomass to hydrogen. We are also working on, that's not a very big challenge, but we are working on the CBG to hydrogen also, so that we can produce hydrogen economically, because all these routes will be green hydrogen. So, so these are the pathways for production of hydrogen. Then coming to the storage part, see, we have developed a Type 3 cylinder at Indian Oil, and this is all approved by various agencies. This is up to 350 bar. Then we are working on now, if we can do something like on the material side, like metal hydrates or metal organic frameworks. So these can reduce the pressure requirement for storing hydrogen. And if we can use some sort of hybrid with some hydrogen at 50 bar or with materials, so that can be a game changer for like storage part. And then ultimately hydrogen storage and transportation can be easier, and it can be used for the transportation purposes. We also did hydrogen CNG studies in buses so that we can reduce emissions. So that is already proven. But for this now, hydrogen cost has to come down, because producing hydrogen at $5 and mixing with CNG doesn't make sense. So the price of hydrogen has to come down further. So we are also working on hydrogen usage in IC engine and fuel cell. So that is also being established, and because hydrogen IC engine is again picking up. So there was a more focus on fuel cell, but now IC engine is again also picking up. Coming to carbon capture side, see, the process of carbon capture is well known by using amines. But what at Indian Oil we have done, and now we have scaled up this process, and we have used some enzymatic intervention for this, so that the overall energy requirement of the process can come down by about 20 to 25%. This has been established well at Tuticorin Fertilisers, and now we are going to scale these plants up for application in the refineries in the coming days. So this is overall like what we are doing to get to net zero goal for the corporation.
Thank you, Alok, I think, for the elaborate answers. I see three real challenges. One is the feedstock management, especially on non-conventional sources. The second is scale up of the technologies which are being developed, and bringing a mutual synergy and compatibility between the transition happening between fossil fuels and blend of, say, drop-in fuels from biosources. And this is going to be very interesting and probably the thrust areas for the future. I'm glad that Indian Oil is working on a gamut of activities. Something which is very interesting, which you have been trying for years, is this metal hydrates for hydrogen storage. Success in that will be something which will revolutionize maybe the hydrogen technology itself as we go further. Thank you. I have a question for Mr. Singhal. How do you see GAIL's contribution to transition, India's transition towards cleaner fuels and sustainable chemicals, especially on C2, C3 recovery, green hydrogen, or bio-based pathways?
Yes. So the biggest strength that GAIL has is, of course, its pipeline network, which can be utilized for, making these plants viable. Reason being, most of the biogas plants which have been set up here and there all throughout the country, they are struggling for evacuation. And again, because feedstock, if you are making through agri route, will be available in a rural area, and rural area will not have a CNG demand. So where to offtake this gas? And if you reduce the capacity utilization, then there will be a question on its viability. So that is where I think GAIL's role comes in, that we can develop. We are in the process of developing gathering stations which will integrate several of these small biogas plants and bring gas, ensure that it is a quality gas, good to be injected in the pipeline grid. Because again, and one more challenge with these biogas plants is quality of the natural gas. It should be absolutely moisture-free. Otherwise, it increases internal corrosion in the pipes. So if we are bringing all this gas to one gathering station and then ensuring the quality, perhaps this can be integrated even into the pipeline grid. Otherwise, as per the practice, till now it is done only in HDPE pipes, MDPE pipes for city gas distribution. Then for achieving our net zero targets, another thing that we intend to do is switch our compressors from being gas-driven to renewable energy-driven. So that is one area coupled with biogas which will make us net zero in scope 2 and scope 3 by 2035. Scope 1 and scope 2 and scope 3. Scope 3 will be only 35% reduction, scope 1 and scope 2. The third is, of course, we have been the first again to set up a hydrogen electrolyzer plant. But as rightly being discussed, as of now, it seems a little far cry because the cost of green hydrogen produced through electrolysis is very, very high. And I think there has to be some other technology, perhaps if we, then only we can see hydrogen succeeding, green hydrogen succeeding. Because electrolysis, if you are consuming so much of electricity to break the hydrogen bond and produce hydrogen, then it will remain costly. And going forward, more so that as we see crude has already come down and with the approaching LNG glut, perhaps gas prices will also be down. So selling green hydrogen even at $2 may become difficult. Therefore, we have to look for something else, some other method of producing hydrogen. That is my feeling. So these are the things, few things that we are going to help achieve, not for GAIL only, but for everybody else also, for the country also to reach net zero. Yeah.
I think, thank you, and very aptly put. We are seeing that between the fossil fuel and the aspirational goal of trying to be completely away from fossil fuels, LNG or gas is playing a key role. And as rightly pointed out, it is finally the economics coupled with our ability to manage the environment which is going to dictate as we move forward on times to come. We move on to Rajesh again. Rajesh, I have two questions for you combined together. One, I would like you to address how CLG's technologies are becoming more carbon efficient and circular in nature, and also address the question of India's need and quest of trying to find various sources for crude and the large flexibility they are seeking towards and insulating the crude sources from the end goal of producing product. How does CLG's technologies and catalyst figure in this?
Okay, thank you. So before I start, first of all, I want to say that thank you, Mr. Prabdas, for really stating it very clearly. So from today on, we are going to rename C2C, which was stood for crude to chemicals, as crude to cash. That's the point. Ultimately, refining and chemicals, it's a business, and you are in business if you convert it into money. So that's good. So you have to have technologies that are flexible enough that can convert your crude into cash, whether it's going one product or another product. So flexibility is important. So the flexibility comes in different ways. One flexibility is that you have to be able to make different products. At CLG, we have capabilities of doing that. The C2C technology, TC2C I talked about, it can at times maximize diesel, if the diesel market is good, or it can maximize naphtha to go to chemicals. So that's important. You also need to have the flexibility of having different crudes, processing. You can take advantage of the pricing. But I have to tell people that that does come at building something extra. Nothing comes free. So you have to have that. Another lever that you have is catalyst. Ultimately, conversion is caused by catalyst. And you have to have catalysts which, all catalysts are not good for everything. So you have mixes of catalysts. So when you are planning something, you got to think about what kind of catalyst I'm doing. There could be some small revamps that you could do in order to make it, bring that flexibility. You talked about circularity. So, that's all going on. We are talking about doing some co-processing, then, plastic pyrolysis, creating the pie oil and recycling that back into this, that's going on. Another idea I have is that, coking, people don't think of coking as something good, but there is a version of coking, and if you have the right kind of feedstock, you can convert and make synthetic graphite. Synthetic graphite is very useful towards electrification in making the batteries. So that is something you can look for. Geopolitics in all this thing going forward is going to play a big role. It is playing a big role, and that's why India is processing so much of Russian crude. Russian crude is not the easiest to process in some things. It is not as easy, especially when it comes to the bottom of the barrel. Each of those has its own challenges. So, you got to work with the experts to develop the solutions. We are one of the experts who can offer, those solutions. But now, ultimately, I also say beyond that, you got to use whatever tools which are available. Now, the tremendous advancements in AI are making it possible for you to take that data and employ it. So the biggest challenge for our industry is there are lots of very knowledgeable people, but everyone eventually retires. And every company faces the problem that, that expert is no longer there. He used to know so much. So how do you capture that knowledge? You got to capture that. So you seeing the advancements of AI, everybody uses ChatGPT, but what does it need? It requires tremendous amount of data to do this. In spite of that, it makes mistakes. Now, in our industry, first problem is the tremendous amount of data is not easily available. It is primarily proprietary data. An operating company is not willing to share its data with just everyone. So that is limited. Now, we, in our case, as a licensor, we work with our affiliate, Lumos Digital. So we do have some access to more data, and others will have as well. But that AI cannot make mistakes, because a mistake in our hydrocarbon is basically you're dealing with explosives. That's a problem. So what you have to do, that the AI in this case is not going to be pure something which runs by just eating up the data. You have to apply first principles in that as well. And that is going to be an effort. So the amalgamation of the first principle plus having a robust AI model is very important. We are looking into using the AI in the design phase, in the development of catalyst phase, in operations phase. And the other thing I talk about is when you talk about AI, and if you want to use AI eventually in your industry, it is not just about what it predicts immediately. It's just like you use APC. There is a time lag. There is a delay. So it's a big challenge ahead of us, and what I tell to the young people in our industry is that don't be afraid of AI coming in. We are an industry which is, there is no room for error. So human intervention, human ingenuity is going to be required throughout.
Thank you. I think, Rajesh, you anticipated my next question as well. So thank you for making my job easier. I still have a question on FCC catalysts and circularity to Mr. Goyal. I'd like you to elaborate on the relevant context of catalysts, especially FCC catalysts on processing biofeeds, SAF needs, plastic to oil, and waste streams as well, to take this whole discussion to a completion.
Thank you very much. Now, being in the industry, oil industry, and to be realistic, there are a lot of things we can do, and we are doing. Of course, we have sustainable aviation fuel, we have catalysts, latest technologies developed for plastics, a lot of those things. But let me tell today, because I'm sure next couple of days you will hear a lot about these, and I got some experts we have a booth number 41. Easy to remember because I talked of 1942. So this one is 41. So we have got some global experts there, technical, also from marketing, and they can tell you the latest stuff about it. I'm a simple operator, so I'll tell you about an operating perspective today from circularity point of view, and it's about the waste management. Catalyst does become waste, or some people think so, after it is used. But look at, I'll tell two stories, a quick one if you don't mind. It will not take more than a few minutes. One is about cradle to cradle, and the other one is from cradle to grave. The solutions that we have provided to our customers, and they are working. So first one is, unlike FCCs, EV catalyst technologies, the used catalyst is more than the catalyst that you add. And that catalyst is oil soaked. It's not easy to handle that catalyst. So we have a customer, a very reasonably large customer in the Middle East. And so we have often offered them a solution, and we are working together with them. We are successful in that so far. The unit is being commissioned. And what we will do is we'll provide them the fresh catalyst from the plant to bring it to that country, store it there, and then supply as needed to the refinery, transfer pods. It will be used in the refinery. We'll take the spent catalyst, which is the oil-soaked catalyst. Then we will ship it across international borders to get this cleaned up, get the metals out of that. In between, some laboratories are involved, a lot of stuff is involved. And those metals then go back to our plants in US, and we again put those metals back in the catalyst when we supply the fresh catalyst, or we give them credit. So what I mean to say, this is cradle to cradle. This is the first time in this region at least, if not the world, where we have deployed this technology. So circularity in the real terms, the catalyst supplied, spent catalyst taken back, metals removed, again put in the fresh catalyst and supplied back. So this is what I like to think, and don't think nobody should think I'm talking like Trump, but it's really beautiful. So that is a solution. The other one is cradle to grave. All the FCC operators, they struggle with the solution to the spent catalyst that they have, what to do of it. So that one relatively easier, but still it calls for a solution. So at two FCC units, both our customers, again in Middle East, in different countries, Saudi Arabia and Oman, we have found solution for them. So we dispose of their catalyst, spent catalyst, within that country, and it goes to the cement plants. So this is something that in India also should be explored. This is a collaboration. Cement plants can indeed benefit. At the same time, you get rid of that spent catalyst. So with these two examples, that's it for now. This is circularity for me. I hope it kind of inquiring minds will have some other things, and when we visit those customers or they can meet us at the booth, we can talk about those solutions for Indian FCCs as well. Thank you.
Thank you, Mr. Goel. I have a quick question for Bharat. The focus of Indian refineries and technically trying to be collaborative globally, but at the same time make in India is something we are all very interested and probably looking towards building this phase of technological growth in the country. Could you quickly tell us something about how you believe that we can collaborate globally for green chemistry evolution in India?
Thank you, sir. You see, I will respond to your question in small portions, but very quickly. First part is collaboration on technology part. So one thing which I feel of late IOCL is doing, HPCL is also doing through R&D, and there are now projects being taken up by GAIL where there is more and more thrust on investing into technology side of business. However, I do feel that collaboration with foreign companies who do have technologies, even if not fully mature, but for the evolving future, there is a possibility to collaborate and get the technology transferred into India for a longer term perspective. So it is little bit of upfront investment right now, which may not be visible immediately as a business which is highly profitable from the perspective that it still needs some investment and maturation of technology. But once we do it at this stage of the technology deployment, then in longer term we can do more as Make in India and indigenized technologies. On the second part, I would say in terms of equipment manufacturing, we as an organization, we are focusing a lot on in-country value. We call it ICV, and we have a directive to involve as many Indian vendors as possible for deployment of our technology. And we are also working on the possibility of exporting those equipment for our technology to be built in India and exported outside. So you can say there has been a focused thrust by which we deploy Indian technology more and more. But on the top of that, as an organization and as a group, collaborating with Indian EPC, Indian stronghold EPC Technimont, we can offer a very strong foothold solution where we can provide solutions maximizing Indian resources as technology and EPC company of India. So you can say that there are multiple opportunities in terms, but if I look at from the perspective of what we anticipate from industry towards us is a little bit of flexibility to participate where even if we do not present, operating reference working for multiple years, but still show a promising technology to participate in a collaboration with Indian companies.
Thank you. I have a last question to Mr. Prabhudas. Global benchmarking, use of digital for operational excellence in turnarounds, project management, and general operations, including reliability, is something which HMEL has been a leader in India. I would request Mr. Prabhudas to share his experience on the same. I know that we are running out of time, but I thought I need to ask this question to him. Mr. Prabhudas. I'll give you 3-4 minutes.
3-4 minutes, okay. Compete with the world. Raj Saab, sun lijiye. Good evening. We had so many experts, and the experts have been added by one more, the greater expert on carbon, Mr. Ranjit Ratso. Thank you very much for joining us. it's not, benchmarking. It's question of survival. You may benchmark yourself and feel happy that, you are in quartile 1, quartile 2. It doesn't matter now. You are competing with the world. Refineries are closing. The European petchems are closing. Korean petchems are closing. Why? They were inefficient. They couldn't compete with you. You will close if you can't compete with China and Middle East. They have advantage. Their feedstock advantage, their advantage I need not mention. You have all the disadvantages. The only advantage which you have is the brain. You have got brain and you have support from the technology supplier, from the catalyst. We can do wonders. And we have done wonders. This competitiveness will come from the money which you make, cash. Thank you very much that, money has been converted into cash. I was analyzing, how do we lose money? Making money is good. Refinery, fuel cost, losses are negligible, 7 to 10%. My turnover is, say, 80,000 crore, 8,000 crore straight away goes in fuel. 8,000 crore. Petchem is still better, 20%. And some people will say 20 is, very efficient. 20,000 crore, 4,000 crore, 12,000 crore gone on fuel. Where is the cash? We are burning. Can't we do something on this? Sustainability is good. These can be combined together. Why do you heat and cool so many times? I'll give you 3 examples and then you will, we have a lot of intermediates. Everybody, refinery, petchem, they are intermediates. Intermediate go to intermediate tank, and before they go to intermediate tank, we cool it down. We spend money to cool them. वो fan pin क्या ऊपर fin क्या पंखा लगा है, cooling, all that. To remove this energy, we use energy. Okay? And then again we bring it back. And again heat it up. Why? Why can't we put AI in this and, remove all these intermediates? You calculate your numbers. I will not. My numbers are very big, and our people are on the job. Very simple. Energy efficiency, everybody must be doing energy efficiency, all this, waste energy, how to use that waste energy, everybody is using it. Are we good enough? Just simple example, I was going through, the steam traps. Steam traps. Or, PSVs. How do you lose energy? Are all your PSVs and steam traps working? No, we check every week. Why can't we put a small sensor there and then you get to get immediately? Small. You don't require brain. Put 1,000 sensors. You reduce energy. I mentioned 12,000 crore is going. So it's not competition. It's not competition, it's a question of survival, and we shall survive. Digitization, everybody, I don't know, simple thing, I asked last time, a professor, I asked, will AI replace human being? The answer was, I don't know, but people who use AI will replace the people who don't use AI. I don't know which category you want to be. I don't want to be in a category, so I use ChatGPT every time, Before I came, I got all the things written by ChatGPT. But coming back to refineries, there's a huge money. There's a huge money. Have you used, most of you must be using advanced analytics in your refinery. If not, then do it tomorrow. All of you may be using real-time optimization, closed loop, not open loop, closed loop. If not, do it tomorrow. Go back. And there are service providers who can really help you out. And we did it on profit sharing. हमारा profit ज़्यादा हुआ, उनका कम हुआ. That's besides. But, there are many players. We do many things, I will give you an example because of time. I will not elaborate on that. But we spent 80 crore and 200 crore rupees. Thank you very much.
Thank you, Mr. Prabhudas. As usual, you built energy and disruption together to make us focus on profitability as the central theme of whatever we do. Digitalization per se is democratization of data, but democratization of data itself does not make money. It is building actionable insights and acting on it, which makes the difference between use of technology and just having technology per se with us. Today, as we are poised to look at a gamut of activities ranging from complex frugal engineering into the old refining systems, to building reliability, to integrate with petrochemicals, to bring sustainability together, and to also exploit the new generation technological tools which are there. It is indeed a complex environment with, as I started in the beginning, a constructive chaos, but potentially with ample opportunities to create innovation and creativity amongst us and this fraternity of refining and petrochemicals and an extended branch of circular economy and sustainability. Thank you. I had the pleasure of being here with eminent personalities in this field, some of them veterans over long periods of time in refining and petrochemicals. I also thank CHT for giving us the opportunity. They also created a disruption to all of us by telling us that you now, in line with how India is working, you also need to be ready for a session which was supposed to be in the evening, first thing in the morning. Thank you, everybody. It's been a pleasure being here.